In this hands-on, we'll explore the functools.reduce function in Python. As discussed in the associated lecture, this function allows us to apply a function cumulatively to the items of a sequence to reduce it to a single cumulative value. Let's start with streaming log processing. The goal here is to count the number of error messages in a list of log entries. In this example, we first import reduce from the functools module. We have a list of log entries and a binary function called count errors. This function takes two arguments, an accumulator and a log entry. It checks if the word error is in the log entry, and if so, increments the accumulator. We then use reduce to apply this function across our list of logs, starting with an initial value of 0. The result is the total count of error messages, which is then output to screen. This very simple example illustrates how the reduce method can be used to process and summarize data from a stream like log files without necessarily having to go through a slightly more inefficient implementation that might involve looping, for instance, and populating the accumulator that way. Moving on to genome pattern recognition, our task is to count occurrences of a specific nucleotide pattern in a DNA sequence. Here we have a fictitious DNA sequence and a pattern ATCG. The binary function countPattern increments an accumulator if the pattern matches a part of the DNA sequence at the current index. Later, using reduce, we iterate over the range of indices in the DNA sequence this way, applying countPattern to count the occurrences of our target pattern ATCG. Lastly, we turn to the stock price anomaly detection example, where the objective is to calculate the average price of a list of stock prices. We have a list of stock prices here and a simple function called sum_prices that adds a price to an accumulator. The reduce function later applies this function across all prices to find the total sum. We then divide this sum by the number of prices to get the average. Since we've now built up some intuition, let's increase the complexity of our examples a little bit to take things up a notch. In this first not-so-simple example, we'll first define a helper function called isErrorLog to check if a log entry is an error, and then another function called countConsecutive_errors to count consecutive errors literally in the log entries. We then use a lambda function with reduce to track consecutive error counts. And this showcases a slightly more sophisticated use of reduce, where a lambda function in combination with a helper function and logic has been used to effectively identify patterns over time in an input data stream. For the next not-so-simple genome pattern recognition example, we extend the task to search for multiple nucleotide patterns. We define a function called findPattern for finding occurrences of a pattern in a DNA sequence. The function countPatterns then uses this to count occurrences of multiple patterns. Later on, with reduce, we apply this function, countPatterns, to a list of patterns, demonstrating how reduce can be used in this case for more complex pattern recognition tasks. And finally, with our not-so-simple stock price anomaly detection example, here we're going to calculate the variance of stock prices to detect anomalies. We have two helper functions to calculate the mean and the variance respectively, and then define a function called sum_squared_diff to compute the sum of squared differences from the mean. Then finally, using reduce, we apply this function to calculate the variance, which is a measure of the spread of data points, essentially, if you're not familiar with the concept of variance. In this example, we're essentially demonstrating how reduce can be employed in statistical analysis scenarios as well. In conclusion, therefore, the functools.reduce function is yet another powerful tool in the higher order functions toolbox in Python, suitable for a variety of applications from log processing to statistical analysis and finance, as we've demonstrated in this hands-on. Its ability is in processing sequences of data in a cumulative manner, making it a valuable function in any Python programmer's toolkit. You need not necessarily be addressing problems in these three domains, but by addressing these problems in this hands-on in these three domains, hopefully we've covered a few scenarios that give you ideas on how to implement the reduce function in your own respective problem-solving scenarios. As always, thank you for your attention, and I'll look forward to seeing you in the next few lectures and hands-ons.